Light. It comes from the sun every morning we wake up and comes from the light bulbs in our homes. We are surrounded by light every day of our lives. It may seem pointless talking about light right now, as we know basic things about it, like it reflects and refracts. But what if I told you light wasn't as predictable as it seemed? What if light had another persona? Hi, my name is Sanjeev Palasari, and today I'm going to be talking about the quantum theory of light. Our basic knowledge, we consider light to be a wave. Light previously was considered only a wave as it could reflect, refract, diffract, and interfere. Refraction of light occurs when one wave passes from one medium to another. The wave undergoes a sudden change, causing the path to be bent. Most people are very accustomed to the fact that light waves also undergo reflection. The reflection of light waves of a mirrored surface results in the formation of an image. Light waves diffract as they spread out when they pass through a hole. Essentially, a smaller hole causes more diffraction. Light waves create interference as well as they collide with each other to either combine or erase. At this point, you may think that it's pretty obvious that light behaves like a wave. So how do we know that light is really composed of particles? Support for this idea comes from an experiment that is called the photoelectric effect. For this experiment, a light is shown on a metal, and after a certain binding energy is overcome, an electron is emitted from it. An important feature of this experiment is that the electron is emitted from the metal with a specific kinetic energy. Now, anyone who is familiar with the behavior of waves knows that the energy associated with the wave is related to its amplitude or intensity. For example, at the ocean, the bigger the wave, the higher the energy associated with the wave. It's not the small waves that knock you over, it's the big waves. So everyone who thought light is just a wave was really confused when the intensity of the light was increased and the kinetic energy of the emitted electron did not change. What happens is that as you make the light brighter, more electrons are emitted, but all have the same kinetic energy. The scientists were perplexed as they thought the kinetic energy of the emitted electron must depend on something. So they varied the frequency of the light, and this changed the kinetic energy of the emitted electron. This result is not consistent with the picture of light as a wave. An explanation that is consistent with this picture is that light comes in discrete packages or particles called photons, and each photon must have enough energy to eject a single electron. Though it might seem impossible for light to be waves and particles, this is called particle-wave duality in quantum physics. This principle causes light to exhibit either particle or wave-like properties in certain instances. Overall, light is composed of particles with wave-like properties. These findings could have been possible without Einstein's theory of photon and Max Planck's contribution of his constant. Hope I shed some light on the topic.